So thank you. Yeah, so I'm Tyler Akidau. I'm a software engineer at Snowflake. I've been there for about a year. I'm working on streaming there. Prior to Snowflake, I was at Google for about 12 years, and most of that time was spent working on streaming as well. And so today, what I'm going to be talking about is an effort that's been going on in the DM32 SQL Standards Committee, an ad hoc focused on extensions for streaming SQL. So it started about a year ago. It's ongoing. And so I'm going to kind of give an overview of what's going on and kind of my opinions of where we're headed. Agenda for today, I'm going to start out by briefly motivating why we're even considering this. Then I'm going to spend a little bit of time talking about what happened in the last year, which was phase one of the project, which was a kind of a public information gathering section. And then I'm going to essentially give my opinions on where I think we're headed with what's happening now in phase two, which is a private recommendation development portion of it. So briefly to motivate, why streaming SQL. This is sort of a simplified history of kind of what's gotten us here. But there's been lots of research into streaming SQL over the years. There was a significant amount of it in the early 2000s. I see a number of faces in the audience from that time, so no pressure. There's a lot of foundational stuff happened then. There are a few kind of crazy or bonkers things that came out as well, but a lot of good stuff happened. Some companies were formed from that, but for whatever reason, it just never really caught on in industry, in my opinion. It wasn't really until the 2010s when I think the Hadoop ecosystem, not Hadoop itself, of course, but things like Storm and other things around it, Spark Streaming, Flink, et cetera, kind of started to step in and, from an industry's perspective, try to tackle streaming. That it really started to kind of take hold. And a lot of this stuff was built by folks who had no idea what had happened in the research community. I joined the Millwheel team at Google in 2010 and was with them for about a decade. And we were kind of aware of the research that was going on, but we didn't really, we were really focused on building systems and kind of meeting what our customers needed. And then by the time you got towards the end of the 2010s, we built all these systems that were using Java or C++ or other languages to do streaming, and they were turning out to be really useful. But then there were a bunch of people that were like, why can't we just use SQL for this? Like, why are we having to why are we having to use Java? Why are we having to write C++? Or, I've got analysts who don't even know how to program. And at that point, then a bunch of these Hadoop sort of ecosystem projects kind of started looking into SQL. And that's kind of where these two paths started to merge a little bit more. And so by the time 2020 rolled around, there was a proliferation of streaming SQL approaches that were actively being used across the industry. And I think this is where the impetus came to say, well, maybe we should start to standardize. And so that's kind of where we've landed with things. And so then this ad hoc within the DM32 committee was created. And it started in, I think, December 2019 with phase one. And then that continued for a year. And then we just started phase two this year. So phase one already happened. I'll be presenting a very short list of facts about it. Phase two is just kicking off. Like I said, it's technically private what's going on there. So I'm going to be presenting my personal opinions on where I think we're headed. I'm not going to be actually presenting any of the stuff that has actually been shared within that group at this point in time. So we'll start with phase one. So phase one was, as I said, open to the public. And what it consisted of essentially was dozens, well, not dozens, but probably right around a dozen or 15 different presentations from various folks who had systems that they had built that were doing streaming with SQL. And then the output of this portion was a summary report that we all generated together that kind of stated what we'd heard, what we thought the open questions were, where we were going, and basically a recommendation to say, hey, we think that it's worthwhile pursuing an actual recommendation for adding extensions to the SQL language. And so as far as presentations go, this is, I think, a roughly complete list. I may have left somebody out, so if you presented and I didn't list you here, I apologize. But you can see there's, we had presentations from kind of the classic database type companies. Oracle gave presentations on both the SQL language, which had roots back in the early 2000s. Research I mentioned. They also presented this other system they have that takes SQL and then executes it using Spark. So it's kind of more of a hybrid sort of a system there. There are a bunch of commercial systems, SQL Stream, Snowflake, IBM Streams, who presented, and then there was a whole suite of open source projects. Most of them being funded by commercial companies as well, but operating in the open source Hadoop ecosystem. So Apache Flink, Apache Beam, which I was involved with, Confluence KSQLDB, and then we also, so there was one group of us, again, within the open source community that included Apache Calcite, which was Julian Hyde, who's presenting next, I believe, folks in Beam, which was myself and Ken Knowles and others, and Apache Flink. We all got together in 2019 and wrote a paper that was published at SIGMOD that basically kind of laid out our opinion of where we thought things should go. So we presented that as well. In an ideal world, I would share with you all the links to these presentations, but even though this section was open to the public, I've been told that the presentations that were uploaded are technically private. So lacking that, anyone with DM32 membership can access these at insights.org. And I suspect many of you out there probably have access through your companies. So you can access the full report, which is 16 pages of summary of what we did. You can access all the presentations. They're also uploaded there. So if you're curious to dive into it more, I'd recommend doing that. But unfortunately, that's sort of the best I can do for here. So now I want to move on to what is, I think, the kind of the more interesting part of the presentation. We're going to talk about what's going on in phase 2. So this is, for this portion, then it's shifted into the private mode. So you have to be an Insights member to participate. That's because of intellectual property concerns. And what we're doing is basically brainstorming and discussing the things we learned in phase 1 and trying to generate recommendations for what SQL standard extensions should be around streaming. The things we need to accomplish in this, in my opinion, are basically identify the key shortcomings in SQL, if any, recommend SQL language extensions where appropriate, and recommend not to extend the language for everything else and explain why. And this is probably pretty much how all of these work, but just to make it clear. But more interesting, and what I really want to talk about here is kind of, we're trying to figure out exactly what the heck do we want to do. And I didn't go into, when I talked about all the presentations that happened in phase 1, just exactly what folks presented and what the differences there were. And so I'm going to try to do that here under this this section of talking through different types of categorized requirements that we see as things you need to think about or care about when you're dealing with streaming, and what we might want to do as far as supporting these types of things from SQL itself as a language. And so I was working on this with my colleagues Dan Sotolongo and Tyler Jones at Snowflake. And it basically breaks it down into things like types and type relationships. So these ideas of streams and tables, what are they? How do they relate? Latency and cost management, balancing wanting to get results quickly versus how much you're willing to pay for them. Temporality, dealing with reasoning about querying at different points in times and things like this. Readiness, knowing that you have all of your data when you're living in a world where your inputs are these infinite streams that kind of trickle in or surge in at different rates and with differing amounts of disorder. Obsolescence, basically garbage collection. How do you not maintain infinite state over time as you process infinite data? Imperative versus declarative approaches. And then what our stance is going to be on error handling. And so what we've been working on is kind of a document that has a bunch of lists of these basically subcategory type things here, and then a bunch of statements that are kind of written from the perspective of a user of like, if I'm thinking about what is a stream, well, what are some examples of what a user might be thinking here? I have a transaction log in Kafka that I want to process with SQL, or I want to export and process CDC data for a table within my database. And you don't need to necessarily read all of these in detail. I put for each of these kind of the full list that we had, because if I had more time, I would talk through these. I think there's a lot of interesting stuff in here. But for each of these categories, I'm just going to kind of call out what what I see as one of the key things that we need to solve. So for these types and type relationships, what are tables, what are streams? I think that really is kind of the key question we need to answer. And interestingly enough, across the presentations, there's a wide variety of opinions on this. So there are those who were strongly in the yes camp. KSQLDB and Confluent take a very strong stance of, yes, these are different. They shall be treated, as two separate things with two sort of first-class objects within this, SQL and the SQL language. There are opinions like those of us who wrote the one SQL paper who are strongly no, and basically saying, look, these things are basically the same things. There are different, there may be cases where you want to materialize certain types of data, like change logs, into something that is effectively a time-varying type of object, time-varying relation, or effectively a temporal table. But at the end of the day, they're sort of the same object. Then you have other folks who are saying things like, we don't even really need streams. The materialized folks are kind of coming from that angle. And then there are many variations of kind of partially yes and partially no. So we're going into this phase 2 with not clear consensus whatsoever on what this is. And I really think this is one of the key things that we need to solve, because it very much dictates kind of where we're going to go with the rest of everything else. Latency and cost management. I mean, there's a whole bunch of stuff that falls under here. Things like giving folks the freedom to choose, the lag of computation for the results. So there's, I think a classic database where you have everything kind of tightly woven together, and it's just this little hermetic environment. Oftentimes, if you have derived views, they may transactionally be updated at the time you update data. But in kind of the big data type systems, this ends up not being practical. So you end up with a lot more of eventual consistency sort of materialization, and folks end up with wanting to say, well, I want these results in within a minute, and I want these results within an hour or a day, and they want to be able to make those choices because it's much more costly to have it come much more quickly. So a lot of times folks want freedom around that. There's a whole isolation question, especially when you start to get talking about transactions and consistency. Do we always have consistent results across these things? Are we okay relaxing consistency? Certainly, the vast majority of databases people use from day to day are not giving you serialized consistency, serializable consistency. Periodic refinements of results. When you're talking about data that or results that kind of get updated as time goes on, how do you want to see those, and how frequently? So I think a big key thing here is just which of these things should be a SQL language concern, if any. Do we want to talk about target latencies in the language, or is this just a system configuration aspect? Isolation constraints are kind of part of the standard, sort of. So maybe that's a thing that should be part of it. Early, late, partial result policies, bounded disorder. These are all, various systems have tried it both ways. And again, we need to kind of come to some consensus of what makes sense and what's useful. Temporality, dealing with time. SQL has these as of expressions that let you kind of reference different points in times if you're dealing with temporal tables. Again, Julian Hyde, who's speaking next, wrote up this doc that I've referenced here a few years ago, kind of explaining one thing he saw as a concern around, I believe the standard dictates that essentially when you query with an as of statement, the time reference in that query is locked as of query compilation time. So if you're talking about writing a streaming query that's going to run for 3 years, you probably isn't going to be practical for that to reference just a specific point in time. You want to be able to have contextual time where you're referencing time from a value in the row in question or things like that. There's other things that show up a lot in the stream processing world around offset position management or rewindability for backfills. These are very kind of practical operational sorts of things. Then there's the whole windowing thing, which I feel like half the time people think is everything relates, or everything in streaming is just windowing. And how does that matter, and how does that relate to things, and what should we do there? So for this, I'm just going to call out that one of the key things I think we will want to do is agree that we're probably going to relax the constraints for time, or the time reference constraints for continuous queries of as of. This seems to be relatively non-controversial, and it's nice to have something that it feels like we might actually agree on without too much argument. Readiness is another big one. Readiness, meaning sort of again, when you're looking at infinite streams of data, how do you know that you have all the data? I mean, this goes all the way back to punctuations and things like that were, again, from the early 2000s research. But there are lots of use cases where you can incrementally process things, and reasoning about your data being complete doesn't matter. But then there are a bunch in streaming that it really does kind of matter for. If you're wanting to generate notifications where you have one chance to give one answer and it better be pretty much correct, you don't want to jump the gun. And a very important aspect of this is if you're wanting to make decisions based off of a lack of data, again, you can't just sort of say, well, I haven't seen any data, so it must be that say you're doing dip detection where you're counting visits to a website. You want to say, okay, I want to throw an alert if the number of visits in an hour drops below 50% of what we expect. If you just sort of evaluate that incrementally as time goes on, well, of course, it's going to be below that threshold right at the start because you haven't seen all your data yet. But at some point, you've got to say, okay, well, is it below the threshold because there's actually a dip happening? Or is it because I just haven't seen any of the data and maybe some of it's late to show up or things like that? So readiness is really important for those types of use cases. And again, I think one of the difficult things we need to discuss here is just how much of this matters and how do we want to do this. There's a vast spectrum of sort of approaches. In the original Apache Beam, we took the approach of saying, well, we'll give you all the knobs, we'll do all the things, and clearly, in retrospect, that was not the right approach, and more complicated and challenging than it needed to be. There's a bunch of approaches that kind of have taken a toned down approach to that, including Beam SQL, and that's more or less what we advocated in the OneSQL paper. There are other systems that just kind of have a bounded disorder approach, and they say up front, we're going to insert some amount of delay, and then we'll reorder stuff, and then from then on, we just order is the thing. There's others that just say, no knobs, just wait for a brief moment and we'll give you the results. And there's been some discussions around, should you roll your own description of what you want things to look like with SQL. Obsolescence, garbage collection. This is a really important aspect of stream processing systems when you don't want to end up holding on to state infinitely or inputs infinitely. The systems that we heard from, there's kind of a wide variety of approaches that folks took. Some have system level constructs. Some have things like Beam have things that bake it into the API itself, where you're effectively describing what you want the shape of your data to be and how you want what completeness means to you. And then when things are complete, the system knows that it can throw it away because it's done with it. So again, this is still sort of a somewhat broad question, but how should users control garbage collection? Should the system just be able to infer it from existing syntax and context? That's a very great way to do things if the system can be smart enough. Or do we need some user policies around this? And should it be in the SQL language or should it be outside system configuration? Again, there's no clear answers here. Another interesting one is imperative versus declarative. SQL is a declarative language, so I think the declarative aspect is fairly obvious, but there are a number of systems that actually take a somewhat imperative approach to doing streaming with SQL. Snowflake is an example of this, and Tyler Jones is giving a presentation later today about Snowflake streams, and using streams and tasks in Snowflake is an imperative approach to stream processing, and it's a way of doing it without that kind of gives users more control in some sense, and it's the classic imperative versus declarative sort of balance. And I think the question we need to solve here from the standard perspective is, does SQL even need to support imperative? Because clearly it needs to support declarative. And again, calling back to what I'd said earlier, the answer here is probably heavily dependent upon what that answer to that first question is. If streams are the same as tables, then probably no. But if they are different, then it's very likely that yes, you will need an imperative approach, because now you can reason about streams as this thing that are separate from tables. Error handling, just really quickly here because I'm short on time. The thing I want to call out with error handling is we definitely need to consider new approaches and figure out what makes sense. Traditional SQL has this built-in query response path for error reporting. You submit a query, you get a result back, or you get an error back, and then you deal with it. In streaming SQL, you don't necessarily have anyone waiting around to react to a final result. And so, but folks hate silent errors. They want to know what's going on. So do you shunt things off to a dead letter queue? Do you report errors some other way. We need to figure this out. And again, maybe this has nothing to do with the standard, but we need to decide whether that's true or not. So in quick summary, again, the phase one already happened. We had lots of presentations. Go to insights.org to look at them if you have DM32 access. Phase two is happening now. Lots of brainstorming and discussion. It's going to be very interesting. We have our work cut out for us, as I'm sure you can see. If you want to join in the fun, please do. I'm happy to help let you know how to join in if you're curious. And that's all I have. Thank you.